You ever just stop and think about a single raindrop? I mean, it falls from thousands of feet up in the sky, but when it hits you, it's just a gentle tap. Well, there's some absolutely incredible physics hiding in that journey. Today, we're going to pull back the curtain on the secret that keeps a gentle rain from being, well, a full-on barrage of tiny bullets.
It's a great question, isn't it? Seriously, if you drop something from that high up, you'd expect it to get going incredibly fast. So why don't we all need to carry around steel umbrellas? The answer lies in a really elegant piece of physics, a concept we can actually watch in slow motion using, of all things, a simple jar of honey.
So, let's set the scene. Our whole story really kicks off with a simple observation, a mystery that anyone who's ever watched a storm has probably wondered about.
And that's the heart of the puzzle right there. We all know raindrops speed up because of gravity, right? But it seems like they only speed up to a certain point. It feels like something is kind of putting on the brakes. Understanding this invisible braking force is the key to everything.
To solve this rainy day mystery, we need to see these forces in action. And to do that, we're going to slow things way, way down with a simple and kind of sticky experiment. Let's talk about the honey jar.
The setup here is just beautiful in its simplicity. We've got a very thick, or what scientists call a viscous fluid. That's our honey. And then we have two objects of different sizes. This little experiment is going to let us see the forces we're talking about in super slow motion. Okay, so when we drop them in, something fascinating happens. Yeah, both balls speed up at first, but then they both seem to hit a ceiling. They just stop accelerating. They settle into a final, constant speed. And look, the bigger ball gets to a faster constant speed, but it still has a limit. This idea of a final, limited speed, a physical speed limit, that's the secret we're trying to unlock.
So what in the world is that invisible force? What's putting the brakes on those steel balls in the honey? Well, the answer has a name, and it's called the science of drag.
This right here is the hero of our story. As any object moves through a fluid, doesn't matter if it's thick honey or even thin air, the fluid itself pushes back, resisting that motion. Think about trying to run through a swimming pool. The water pushes against you, right? That pushing back force, that's viscous drag. Now, this whole pushing back thing wasn't just a vague idea. Back in the 19th century, a truly brilliant physicist and mathematician named George Gabriel Stokes basically cracked the code. He didn't just describe the force, he gave us a precise formula to calculate it.
And here it is, his elegant solution, Stokes' law. Now I know, it might look a little intimidating with all the symbols, but trust me, every single part of this formula tells a piece of our honey jar story. Let's break